Okay, now this video is for 4.3. Now this is concerning rational functions. So rational functions. In this section, there are 4 parts. I will do 2 videos for 2 parts each. The first part is the definition of what a rational function is all about. So this is the first part. So rational function, this is a 2 polynomial functions that in a form of division. So this is look like a fraction. And on top, the denominator or numerator is a polynomial function. Now the denominator is also a polynomial function. So let's take a look at some of the example here. Now, first of all, this one, because there's no equal sign, so this is not either equation or it's not a function. So this is what it's called a rational expression. Now, the further examples, they all have equal sign. Now, for example, the b, yes, this is a rational function because it's a polynomial function. This is also a polynomial function. Now, the c looks like this is just a polynomial function, however, or even just a quadratic function. But if we give it over 1, then that means, yes, it is a rational function. However, the d is not a polynomial function. It's not a rational function because the denominator, root of x plus 3, is a radical function. Now, the second part is asymptote. This is a very, very important concept in rational functions. Asymptote, so definition, what is asymptote? So asymptote is either a vertical or horizontal line. What is this line is about? This line is not part of the graph. This is not part of your graph, but it is the graph that gets very close to this line. Never gets to the line. It does not cross a line, but gets very, very close to this line. All right? Never reaches to this line. Okay, so now, for example, what is this all about? The very simple rational function could be like fx is equals to 4 over x. Now, here we know x cannot be 0. Because if x is 0, there's no such a function here. So now, therefore, you can give yourself a table value to draw these 2 curves. However, at the value of 0, there is no such a value for x because x cannot be 0. Therefore, this vertical line, which the equation is just x equals to 0, is the vertical asymptote. So, because we also talk about either it's a vertical or horizontal asymptote, now we're going to divide them into 2 parts again. So this is a part 2, but the first one in part 2. We call the vertical asymptotes of rational functions. So what is that? That means your hx, if your rational function is gx over hx. Now, if a value for x that makes hx become 0, so if c is a value, when x equals to c, your hx will become 0, then in that case, x equals to c is a vertical asymptote. Using some example to explain further, now take a look at this. This function x over x power of 2 subtract 9. Okay, so let's factor this. It becomes x plus 3 x minus 3. So therefore, we know x cannot be either negative 3 and positive 3. Because when x equals to these two values, your bottom will be 0. Therefore, your x equals to negative 3 and x equal to 3. These two vertical lines is your asymptote. So if you have this one, so here, if it's your positive 3, here is your negative 3, then your vertical asymptote is these two vertical lines. All right. Now the next one is just a further review of factoring. So then we pull the x out first, and then you have x minus 2, x plus 2, and therefore when x is these three values, your hx will be 0. So then these three lines, vertical lines, are the vertical asymptotes. Now the second part is the horizontal asymptotes. This one is a little bit more complicated. So this one, what it says is that we wanted to always know the end behavior of a function. We talked about this in polynomial function. In that chapter, we talk about end behavior. So it's very important to know at the end of the graph where it goes. So what we're considering here is that when x approach infinity to the positive infinity or approach negative infinity, where does our graph go? Okay, so just randomly draw a graph. So for example, you would got some kind of graph like this. So a graph like that. All right. Now when x approach positive infinity, note that our y value, our fx, is forever approaching, sorry, bad drawing, it doesn't reach this line, and forever approaching this line, but it does not get to this value. For example, if this is 2, if then this is negative 2, so that means when your x approach positive infinity, your fx is approaching to 2. So therefore, this line, your fx equals to 2, is your horizontal asymptote. Now here, when your x approach negative infinity, then your fx is approach negative 2. Then your y equals to negative 2 is your horizontal asymptote. And also note, when I drew asymptote, the two lines, I did not draw just a line, a solid line. Because if you draw a solid line, it is very easy to be confused whether or not this line is also part of the graph. This line is not part of the graph. So you must, when you draw asymptote, you must use dotted line. That means this is not part of the graph. It is only to show that your graph is forever approaching to that line. All right, so now the horizontal asymptote of irrational functions is given by this 3. Now to say your polynomial function for your gx, your highest power is m, and for your hx, your highest power is n. And if the top is smaller than the bottom, then this is your asymptote, horizontal, which is x-axis. But if they're equal, then it's just the first coefficient, and then it's just this fraction of the coefficient. or they call the ratio of the leading coefficient. Leading coefficient, the first coefficient. But then if this m is larger than n, there's no horizontal asymptote. Okay, let's see why is this. So using the following example, it is easier to see how we can prove this. So now, for example, if we're using this function here. Now this function, the m is 1, and the n is 1 as well, so they're equal. So therefore, the horizontal asymptote should be 0. Now let's see why it is 0. No, sorry, not 0. They're same, so it should be just 2 over 3. Now let's see why it is 2 over 3. So the strategy is to divide the top and the bottom by the highest power in the bottom. Okay, so that means divided by x. Now this one divided by x, this whole thing, 3x minus 1 divided by x. Now the top, of course, this cancels, so the top becomes 2. Now the bottom, this one divided by that becomes 3. This one divided by that becomes x, 1 over x. So now take a look at this. When x approach to infinity, then this whole thing would approach to 0. So therefore, we got 2 over 3 subtract 1 over infinity means subtract 0. Then that is the y value, means that when you approach to infinity, this y will be that. But it's not getting to be there because you cannot really calculate infinity. It's just approaching. Therefore, your y is approaching to this line. Now this line, it is just a horizontal asymptote. Okay. Now here we go. The bottom, this is power 1, this is power 2. So we're going to divide both top and the bottom by x to the power of 2. So this is x to the power of 2. 1 over x to the power of 2. This is 2x over x to the power of 2. So then you can cancel that. And the bottom is, this one cancels, become 1. This one cancels, becomes 4 over x. And then this becomes 3 over x squared. Now similarly, this would approach to 0 when x approaches to infinity. This would approach to 0 when x approached infinity. Now very similarly, this is 0, this is 0. So now we got 0 minus 0, and then the bottom is 1 minus 0 plus 0, so it becomes 0 over 1. Therefore, your horizontal asymptote is fx equals to 0, which is just the x-axis. Now this one means the top, the power is larger than the bottom. So in this case, we still divided by the bottom highest power, divided by x. So this divided by x, this divided by x, this divided by x. Similarly, they'll divided by x. Now it becomes this, subtract that, and this approach to 0, that's fine. Now this also approaches to 0, that's fine. But now you got a 2x here. Therefore, when you 2 multiply by infinity, you ended up an infinity number. Therefore, there's no horizontal asymptotes. All right, so now the third part and the fourth part, which is the intercepts and also the holes in the graph, that please see another video.